Hey guys, today I'm gonna show you a really cool project that we at Hackachain are doing with Phala Network. It's called Bazk, and it's going to be exploring all the ways in which zero knowledge and trust execution environment can be merged together to create new and better privacy products.
Oh my gosh!
So essentially, we at Hackachain have been working with ZK for a long time, and our main goal has always been to create new and better privacy systems that allow extensible programmability and extensible private states. You can build anything that is private, and you can choose who can learn any information. This is our overall goal. We have been doing this for a while. When we came across Phala, we were really fascinated with how this network works. Essentially, Phala is a DP network that's trying to substitute a lot of compute services that you would normally find in AWS or other centralized services. Let's think about Phala real quickly. If you think about AWS and Phala as different things, so AWS, you provision a server. So this is your server, you're paying for it, you have a server online, and you put some code in it, you run up your program in it. And people can just come and interact with it online through an API, for instance. It can do anything that you want it to do. But there are some really big problems here when you go into a Web3 setting. First problem is you can't know what is inside of this. So the developer can just change this code, for instance, to something that's malicious, or this code might be doing something that you're not aware of. The owner can just come and read all the data in here. So you have to really trust the person that's provisioning the server. And this person is first a company that's paying for the server and that's doing the code, but also AWS and everyone that provides AWS with machines and software and all the value chain of infrastructure. So you have to trust all of that. And it's very easy to see that in a Web3 setting, this is not ideal. Let's think about an Oracle. You want to be pulling data from, let's say, NASDAQ. So I want my software to pull data from NASDAQ of prices and just put it on Ethereum so that Ethereum smart contracts can use it. So an off-chain Oracle. You can't do that on a centralized server because this becomes a point of attack. If anyone's able to hack the server, they can just send random information to Ethereum and it's going to be accepted because the server is the same. So I have to trust this, and this is why this is not ideal for a Web3 setting. What Phala does is instead of having a server, they have multiple different people running nodes, which are similar to how servers work. So let's think about this as a very big network. And each of these nodes is able to run off-chain computation exactly like a server would, but in a Web3 setting. How's that possible? So basically, they have smart contracts just like Ethereum. They are called fat contracts. And whenever you create one, they have two different functions in them. One is transaction, which is just like Ethereum. You send some data, you pay a gas fee, and they update the contract. And the other is query. And query essentially is a function in which one of the nodes is exposing an HTTP socket to the outside world. So anyone can interact with it, and you can build any logic that you want in here. You can just write a contract that does it, like a server would. And the node itself, or actually any of the nodes in the blockchain, none of them learn anything about your computation. So you write your code, they know what your code is, but they don't know the input you're sending, they don't know what it's doing, and they cannot make it do something that you don't want it to do. So you don't need to trust any of the nodes to run your computation. Just by trusting the protocol, the network, you're able to have this work. How's that possible? It's possible because of something called trusted execution environments. These are chips, like physical chips. They are built by Intel, AMD, or other manufacturers. They have some guarantees. They are entirely encrypted. You can actually run anything in here, and the computer where the chip's running doesn't learn anything about the content. So I could have private keys in here. I could have bank account details. I could have anything coming here. It's private. And that's all because it has a private key infused in here that can encrypt stuff, and it's built by the manufacturer. No one can learn it. You can even do an SSL handshake with it. So you can, if I'm sending private data here, I can just encrypt it with the public key of the chip, and I can make sure that not even the server that's running the chip can learn this information. So this is a very strong privacy guarantee that allows you to have private smart contracts running off-chain servers on top of this. So on Phala, you just kind of rent compute space by paying those nodes with tokens, and they run your contracts so people can actually like query things and use the servers on a decentralized network. So essentially decentralized AWS with a lot of privacy guarantees. And this is awesome because one of the things is TE, they have some kind of a bad reputation in Web3 because they are built by Intel, AMD, like centralized companies, and they have been hacked lately, so they have vulnerabilities, they have sidechain attacks, there are things you have to be careful with them. But at the same time, they are super amazing new tech that allows you to do privacy really fast. You can have really fast programs in there, way faster than in ZK or in MPC. And at the same time, they are very good and very trustworthy for most use cases. So it's pretty nice to have them. And when we first came across Phala, we were just building a ZK app that was really bad at UX because it took like 30 seconds to build a ZK proof on the browser when we wanted to build it. And they were like, how can we actually make this faster? We can use other proof systems, improve the circuits. But we just thought, what if we just offset the computation to a server? Well, this would make it faster, but then the server would learn all the private information. We just thought, okay, but if it was Phala, they wouldn't. Like, this is a private server, it's gonna take your information, build your proofs, and no one's gonna learn anything about it. So that got us interested. Okay, let's talk to those guys. And talking to them, we actually found out there's a lot of stuff to be done here. So basically, I'm just erase those. Phala has a very nice tech stack and a very nice team. And we just realized how much it can be integrated into ZK and how much ZK can make Phala better and Phala can make ZK better. So I just mentioned a way in which you can do this. We can build proofs inside of Phala for our own website. So let's say I have let's say Tornado Cash or some sort of app like this that lives on Ethereum here, and I have to build a ZK proof as a user to send there. This takes a lot of time for me, like 30 seconds. I can just send the computation to Phala, they do it in like 1 second because it's a powerful server, send the proof back to me, and I send it to them, and the privacy is kept. This is super cool. This was the first use case we saw. Then we also saw like these apps, they have trusted ceremonies. Basically those ceremonies, when you take your ZK program and to initialize it, you need to have a secret number and do the entire toxic waste thing. I'm also leaving a link below here explaining this more in depth for those that don't understand how it works. But basically Phala allows you to have more entropy into your ceremonies, so you can just generate like random contributions from different random nodes in Phala. So you just think about like a contribution. You can host a fat contract with the contribution. A lot of like users off-chain can generate the contributions and send them here as transactions. And a lot of Phala nodes can actually send other contributions from their TEs here that are ensured to be private and not tampered with. So you can improve the speed and the entropy of ceremonies, and you can actually host the entire ceremony on-chain for Graph16 apps, because TEs are way more efficient than normal smart contracts. They hold more data, they can do more compute. So instead of having to have your own servers on AWS or somewhere else to run your ceremony, you just do it all in a decentralized on-chain manner using Phala. So we just realized that was possible too. And the final things we were realizing is, okay, actually, we can actually make TEs better than they are. Like, because people don't trust TEs because they know that, okay, there are vulnerabilities. If I trust the results of a TE computation, they can be corrupted by people reading data or stealing private keys or by Intel's API going down. But what if we just take a fat contract from Phala and we input a ZK circuit in here so that anytime it does anything, it chunks out the result of the computation plus a ZK proof that it was correct. If we have this, actually any kind of DeFi app, no matter how decentralized it is, how much it wants to not trust any central player, can just trust fat contracts because they're actually trusting a zero-knowledge proof that the computation was done correctly. So there's a lot of potential here to actually unlock off-chain decentralized computation that is totally trustworthy because it actually uses two very strong primitives. You have all the security in TEs, which is not perfect, let's face it, but at the same time, it's like 99% of what you need for security. And you just throw ZK on the top to make absolutely sure that no one has tampered with anything. So you can actually have like fully verifiable queries into Phala that allow like co-processor functionality for smart contracts, allow oracles, and allow a lot of different stuff that is just decentralized and trustworthy. This can allow you to have private state on Ethereum. You can just have callbacks going from Ethereum contracts to Phala that's processing things, fetching them into like private databases, updating private state, and throwing them back on Ethereum. So this is actually like, after this first idea, we just found out like by merging ZK and TEs, you can get a lot of very, very cool products and very interesting technology built. And this is what we're focusing right now. This is the BaseZK project. So BaseZK is essentially this: how do we take ZK and TEs and build the next generation of privacy-preserving computation products for Web3. Let me share our roadmap with you guys. So BaseZK, essentially we have 4 major milestones we're looking at. So let's think about K1, K2, K3, and K4. So what we're working right now is the simplest of the use cases, which is simply decentralized ceremonies. So this is going to allow anyone to start a zero-knowledge Graph 16 ceremony fully on-chain without any sort of centralized infrastructure, and add contributions from random Phala nodes that are actually private, and so they don't know what they're contributing, they're just computing and making the ceremony more efficient. So this is the first milestone of how to integrate ZK inside of Phala. Going from here, we're actually making the proofs. So how to build ZK proofs inside of Phala. We have made a lot of progress here as well, so those 2 things are almost finalized on the backend parts actually. We're more like doing front-end and more product research right now, but this is going to allow anyone to deploy their zero-knowledge circuits inside of Phala and have people build proofs using the Phala network. So like way better UX for end users, especially in privacy-preserving apps using ZK. Works with any kind of proofing system. Q3, we're doing verifiable fat contracts. So this is the next step. This is adding the power of proof building inside of Phala that we just built here into any Phala computation. So the idea is building some sort of library or SDK for you to code fat contracts in Phala that adds proofs of correct computation. So whenever you do some code on Phala, it's also going to be outputting a proof that the computation was correct on ZK. So we have a proof from TE, like a TE signature showing it's correct, and also the ZK proof. You don't have to trust either. You can require both to be true to trust the computation, so you can be extra sure that no one's tampering with your data and your decentralized servers are doing what they're supposed to do, even if someone tries to hack them. And finally here, we have what we call a common private state over Phala, which is how can you use Phala as a co-processor so that you can have private computation happening and store private state on smart contracts that are on Ethereum, on Solana, or on any normal blockchain. You're going to be able to build private auctions, you're going to be able to build private voting systems with a lot of state being stored. Any sort of system that you can think of. You can think of a dark pool like central limit order book, all built inside of any normal blockchain using the power of processing and private data that's inside of Phala through the use of ZK plus TEs. So there's a lot of cool stuff we're building, and the idea is actually raising the bar on privacy levels by merging all the power and performance of TE and their security assumptions with the power security hardness of zero-knowledge proofs. So I hope you'll find this interesting. If you want to learn more of the project, just get in touch with us. We're going to be having more of those talks lately. So if anyone wants to join or ask any questions, feel free to do so in the comments. And that's it. Let's go, Phala.